Hello, this will be my second video. So as I promised, I prepared the second version of the algorithm for the grasshopper. So you can see now there is a bracing, vertical in the longitudinal direction and in transverse direction, and also the vertical bracings for the pipe rack itself. So I will not go for the details how I prepared algorithm and so on. If you are really interested in it, so please make a comment. If there is enough comment, I will go more detail for this algorithm, how it was done. But here mostly I just will show some details, how it was done, and maybe how it can work. So just some parametrics options, for example, depends on the height of the pipe rack. The bracing could be in this node or another one, and also depends on the height and the width of the pipe rack. Vertical bracing could be kind of one, or this is just show another angle, and two kind of levels or three levels. So rest of things, I think this is clear. You can see my last video. Also another interesting things, I add some eccentricity. For example, here you can see oh sorry, right, so it could be 50, just really close to each other, or maybe 200, kind of like this. Then you can see this is all automatically linked to the RFEM as well. Just let me just briefly change something. really short one, which is okay, kind of random clearance, width, narrow or wide. So all the same, so all the logic. And again, if you want to know how to do this, just let me know in the comment section. But now actually my video mostly about how to make this link between the grasshopper and the RFEM. So as you can see, I have RFEM 5.29. Then if you install RFEM and then grasshopper, so you actually automatically can get this panel. I just also want to say that for RFEM6 the interface is much better, but I don't have that. So I hope in the future I also will make a video how it will be linked with the RFEM6. But now here we are. I also know that a lot of people still use RFEM5, so I think it will be really useful. Just a little bit show how it can work. So you can see we can make a support. The rule is simple. You can also see it here. -1 rigid, 0 it means free for support, and if you have a value you make a sprint support. So that's, for example, just briefly. Now I have a normal hinge support, but if I want to make some like a rigid support in the vertical direction, sometimes it can be useful. We just make it kind of like this, and then let's say I don't know, 500, 5000. Oops, why it's like this, but I think it's kind of sliding that direction. Looks strange, but I think you can actually got my point. So now we have a sprint in the vertical direction, and yeah, sometimes you probably could need it, but let's just delete it. Looks really strange for me why it's now like this, but okay, let's just change it back. I have a mistake about, no. Oh, okay, I think we need to change something, and okay, here we are again. Okay, whatever. So this is simple. You have a nodal support menu from here, the same. Then you have a rule, -1 rigid, 0 is free, and if it's a value, so you have a sprint support. So let's just change back. I need a normal hinge support. All right. Then for this one, you just need to go to the input tab. Input tab. This should be here. Yeah, exactly. And what is really important, you make units in millimeters. So how you can make it? This is a actually special component in Grasshopper, so you just can make it. It's like a value list, and then value list you just can connect with the units and choose millimeters. This is really important because afterwards here in RFEM you can have a correctly exact dimension which will be in meter. Because normally RFEM you apply all units in meter, but here, for example, in my Grasshopper, I have all units in millimeter. So this is kind of like a link between millimeters and meters. Just pay attention. Then what we need to do, I will not show all of this, but I think because all they are the same, we need to make a member. So we need to link our geometry in Grasshopper or in Rhino to the geometry to this here options member as a list. What is it? Actually, this is member component. So this is simple. I think this is clear for you, but what is important to pay attention, this is how apply material, how apply section, and also later on I will show how to apply end supports. For material, you can see that you need to apply materials exactly like it is in the RFEM. So, right, you just actually create any material and just copy to be really sure that this is all what you need. That otherwise, if you make it not correctly, for example, I can say you just make, I don't know, S235 and just say okay, right? You still will have this steel, but actually RFEM cannot understand the physical parameters. You can see all of them zero, and when you start calculate, you just cannot make it. And for section, just pay attention for the gap between HEA and like 300. I think this is quite clear. This is also, I want to show you how you can make a concrete. This is just random for your example. Just you will know how to make some export import with the concrete members. Of course, in the real life it cannot be possible, but generally material is still the same, like from RFEM, and the section just rectangular, and this is how you should make. Then let's go to the member hinge. We can see that my member have a hinge from the end and from the start. So the rule is also simple. Member hinge, you have a component from the top, and then there is a rule, -1 rigid or 0 is free, and value is a spring. So you actually don't need to put -1. By default it will be still rigid, so as we can see in this beam. Alright, and we just make a free rotation along Y and Z axis, which is actually model hinge support of our beam. So I think that's it today, what I want to grab your attention. All other elements, they have the same link with the original geometry from Grasshopper. And then we set material, we set the section, and then go to the input tab, and then here we are. So just that you will see that it all work. Let's go with the start calculation. So as usual, we make a simple load case by the self weight. It is ready now. We just show results, say okay, and here we are with our results. So we also can see that all results looks reasonable. And yeah, that's it. This is how link between Grasshopper and the Dlubal RFEM can work. I really appreciate your comment. If you have any question, just let me know. And also, if you have any idea, if you want to know something more about Grasshopper, Tekla, Dlubal RFEM, or maybe even some AutoCAD topics, you just can put all your wish in comment section, so it will motivate me to make something new. That's it. Thank you so much. See you next time.